Alright, good afternoon everyone. My name is Gabrielle Acosta and today I'm going to talk about the results that we obtained last week when we did the bomb calorimeter experiment. So last week for lab we wore the appropriate PPE and we read and understood the safety guidelines and protocols as well as the lab manual. We then performed the experiment and collected data, and from that data I have results that I'm going to talk about in a minute. So a little background on the experiment we did last week. So we had two samples. One was the benzoic acid and the other was Skittles, and they were both experimented on separately. So the sample was placed within the bomb, and then the bomb was closed tightly and then purged and then submerged within the calorimeter. And then the bomb was ignited, and then the heat that was given off of the bomb was conducted into the water, and then we measured the temperature change of the water. This is the apparatus that we used for the experiment, but I'm not going to go too deeply into that. The objectives of the experiment was to become familiarized with the calorimeter and then determine the thermal capacitance of the calorimeter and the gross heat of combustion of the sample. Here is the data that we collected. There were 600 data points total that was collected, but only some of them are shown here. This is the temperature of the water that changed over time as the sample, which was the benzoic acid, was heated within the bomb. The initial weight that we started out with was 1.03 grams, and the nickel chromium wire that was placed within the bomb was about 4.5 centimeters in length after the ignition process, and it started out as 10 centimeters. Here is the 600 data points in a graph. The first 2 minutes of data was about transient, and then this was was like baseline data, and then the rest was transient data. And you can see when about after 2 minutes when it started to change in temperature after the ignition process. Here is the Skittles collected data. Again, this is not all of the data points. We had about 264 data points, and this is again the temperature change over time. We tried to get the Skittles weight as close to the benzoic acid weight as possible, but we got it to about 1.02 grams, and the benzoic acid was 1.03. And so after the ignition process, we had about 6.5 centimeters of the nickel chromium wire left, and again we started out with about 10 centimeters. This is the collected data over time. The reason for not having the straight line was because we didn't press record soon enough, so that's why there's not that whole 2 minutes of baseline data before the transient data. So I needed to determine the overall thermal capacitance of the calorimeter. So that equation at the top was given in the lab manual. And using the minimum and maximum tools in Excel, I was able to determine the temperature values and get the temperature difference. And I looked up the heat of combustion of benzoic acid, so that value was given to me. And then I was able to plug in those values and get the thermal capacitance at about 95.66 joules per gram per Kelvin. Then I used that value to determine the heat of combustion of the Skittles. And so then again, I used Excel tools to find the minimum and maximum temperatures of the ignition process when Skittles was the sample, and was able to move the equation around and determine that the heat of combustion was 26.28 kilojoules per gram. These are my sample calcs, and I have the reference there of where I found the heat of combustion for the benzoic acid. And then there it is when I solved for the heat of combustion value for the Skittles. So the benzoic acid's heat of combustion was about 100 joules higher than the Skittles heat of combustion, and then this would explain why when the benzoic acid was used in the ignition process, it burned a lot more of the nickel chromium wire than when the Skittles was used. And an experiment such as this one would be beneficial in the calorie value of foods and heat combustion, thermal capacity, temperature differences, and whatnot. Heat theories are my references, and I do want to make note that the data we obtained was in a different language somehow. So the data that I just talked about was from Austin Berg's group, but he's referenced here. And thank you. Are there any questions?